Okay, we're live. Hello, everyone, and welcome to the fourth live session of the RAG and Agents Bootcamp by AI Planet. We're delighted to have you with us today for an exceptionally insightful and informative session. I'm Shivaya Pandey, and I'll be moderating today's session. So, for today's session, we are thrilled to have Tarun Jain as a speaker with us. So, Tarun is a data scientist at AI Planet, a Google developer expert in AI/ML, a Google Summer of Code 24 participant at Red Hat Lab, and a Google Summer of Code 2023 participant at CM Microscope. With his extensive expertise in AI and data technologies, Tarun is dedicated to advancing the field and sharing his wealth of knowledge with the community. In this session, Tarun will walk us through the evaluation process of retrieval-augmented generation pipelines. We will delve into BeyondLLM, which is our own pipeline, which we use for evaluating RAG. We will also have hands-on aspects of the process for better understanding. And at the end of the session, we will also have a walkthrough Llama Index. So I think without further ado, we can start the session.
Yeah, thanks for the introduction. And hey everyone, welcome back. So today we will be doing live coding on how you can build a RAG pipeline using Beyond LLM. And we'll also talk about what Beyond LLM is and why we have built Beyond LLM. And without further ado, let me share my screen. Is my screen visible?
No, it's not. Okay, yes. Yeah. Yeah.
Cool. Yeah, so welcome back everyone. Today we will mainly talk about how you can evaluate RAG pipeline and how you can build one using Beyond LLM. And the introduction I've already done in the module one, and also Shiva has given a brief introduction. So probably I'll skip this part. Cool. So talking about Beyond LLM, right? So since you are already familiar with module two and module three, where you have worked with different examples with Llama Index and LangChain. So when it comes to building a RAG pipeline, there are different retrievers. You have hybrid search, you have re-ranker, you have other raptor and other techniques that you have in building a RAG pipeline. So when we built Beyond LLM, the main vision was to make a quick experimentation so that whenever we are building this pipeline, we know which method is giving us a better result. So this is where the first motivation was that we need to build any application in a rapid speed so that we can do quick experimentation so that we can design which particular methodology is working best for our use case. And secondly, we have evaluation. So large language models are good when it comes to generating the response, and it has done a massive leap when it comes to building a RAG pipeline as well. But how do we determine whether the responses that we are getting are right or wrong, or what is the validation behind it? So this is where we have also added evaluation, where you can evaluate your RAG pipeline uh, based on whatever large language model you are picking. So it's not that you are only supposed to pick OpenAI to evaluate your RAG pipeline. We also have different LLM support, such as Gemini, then Claude Sonnet by Anthropic. Then you have Hugging Face, which has open source models, and you can use Mistral from Hugging Face. And you also have support of Olama. And everything I'll be showing during the code demo. And next comes observability. So what observability does is, suppose you're using OpenAI, each API call that you make to the server, you're spending certain dollars. So if you want to keep track of the entire cost that you are using, not just cost, also the latency for each API cost and how many tokens you're utilizing, whether it is the input token, whether it is output token. So observability will help us to keep track of tokens, latency, cost, and what is the response given by the LLM, so that in the long run, if you want to evaluate your RAG pipeline and if you want to keep track which prompt gave you the better result, then observability is one. So combining all these four, right, quick experimentation with different retriever techniques, evaluation of RAG pipeline, observability, all these things can be done using Beyond LLM. And the best part is you just need to write 7 to 10 lines of code to able to achieve this. So let me revise like what is RAG in the first place. So now let's suppose you have a user. User will enter a query. So based on the query, it will be converted into embeddings. So why embeddings? Because you need to get the schematic meaning of it. And once you get the schematic meaning, you look into the vector database, and based on the search technique that you are performing, you are getting the relevant documents. So this is what happens in the first step. And once the relevant document is fetched, you also need to format your prompt. So formatting the prompt in the sense you need to give certain instruction to your large language model so that it can perform well. This is where once the user query is given, you need to create a prompt template where you are giving certain system prompt as well as user prompt, which has the instruction that a large language model needs to perform. And once the prompt is augmented, you have the updated prompt, which happens in the second step. In the third step, you will take the output of the first step, which is the context, and you will also take the input from your prompt, and then you will pass it to the large language model and you get the response. So this is how a typical RAG pipeline usually works. So now let's talk about how you can build RAG with just 5 lines of code using Beyond LLM. And you have a demo as well. If in case you want to check the Collab notebook, you can check out this link. If not, we will be doing live coding. So it's like you don't have to follow any Collab notebook. I'll just write the entire code from scratch so that everyone can follow along with me. So you can skip this part. I'll just show you how the entire framework looks like. At first, we are using Gemini model. So Gemini is the default LLM and embedding model that we are using for Beyond LLM. And once you set up your API key, the next step is you need to add your data. In order to add your data, there are different data sources. You have PDF, you have CSV file, you have YouTube video, you have Notion link. It can be Drive. Any external data that you have, you can pass it to the source.fit and you can extract the data. So when you're trying to extract the data, it is not supposed to extract the entire context at once. This is where you're supposed to do chunking. And we have two different parameters that you can define. One is chunk size and one more is chunk overlap. So now let's suppose if you have a very large document, you divide that into smaller chunk and you have multiple chunks of a smaller size. And if you want the overlapping between one chunk to the next chunk, that's where you can define chunk overlap to be certain token value. And once the chunk fit is done, you need to retrieve the relevant documents. This is where Beyond LLM comes into the picture, where it helps you with a lot of time. So if you look at type equals to normal, basically, whenever you're building a RAG pipeline, you're using normal vector search. In our case, what you can do is, if it is a normal, you're doing just a vector search. If you're choosing cross re-ranker, you're doing re-ranking technique. We also support hybrid. So it's like you just have to change one single parameter and you're able to get the relevant document without even writing extra lines of code. So this is where quick experimentation comes into the picture. And next we have generator model. So what generator model does is it takes the user query, it takes the retrieved context and it passes to the LLM, which is Gemini by default, and it creates the pipeline, what you saw in the step 3 of the workflow. And then we use pipeline.call to generate the result. And if you want to evaluate, then we have something called as get RAG triad evals. So stressing about what get RAG triad evals is, you have three metrics. One is context relevancy, one more is answer relevancy, and one more is groundedness. So what context relevancy does is, whatever context you get, whether the response from the LLM is matching with the context or not, this is what context relevancy does. Second, you have answer relevancy, whether the answer generated by the LLM is matching the question or not. Third, you have groundedness. So what it does is, you have an LLM, it tries to generate the data set within it from the context, and then it is evaluating based on the ground truth whether the answer is correct or wrong. So in each of the metric, you are getting a value on the scale of 0 to 10. If it is more than 7, that means your pipeline is doing good. If it is less than 5 or if it is less than 4, then you need to update your RAG pipeline and you need to do improvements in chunk size, different retriever, top K value. So if it is less than 4, there are different hyperparameters that you need to tune. And this is where, if you have a Beyond LLM library, tweaking the small parameters, it will take just a few minutes. You don't have to change the entire code. So it's like just parameter change. So this is why we wanted to have quick experimentation along with the evaluation of it. Cool. So yeah, since my main talk of today's session is to have live coding, so this is the end of the slide. We'll be doing live coding now so that you can open your Collab notebook. But before you can open that, we have the GitHub repository, which is completely open source. What you can do is you can head out to this GitHub repo, and we have a context. So context is nothing but you have this cookbook, and you have these examples. If in case you are after the session, if you put any example of yours within this two folder, then you will be getting few swags after the end of the bootcamp. And you can check out the GitHub repo, and we'll also have the slides again by the end of the talk. So cool. Let's start with the live coding. But meanwhile, if there are any questions, we can take this.
Okay, we don't have any questions yet. I think we'll have at the end of the session then.
Got it. Okay. So we'll wait for 1 minute, or else I'll share my screen of Collab Notebook. Okay, so is my Collab Notebook visible?
Yes, it's visible.
Okay, so we'll be writing code. You can write the code along with me, and it's just 7 to 8 lines of code, and you'll get your results within that. And in order to get started, the first step is installation. And in order to install the Beyond LLM, you just have to write Beyond LLM. And since our external data is a YouTube video, you need to download YouTube transcript API and Llama Index readers, YouTube transcript. And you can also follow along with our documentation. The documentation is at beyondllm.eiplanet.com. So it will take few seconds, and then we can get started. Cool. So once the installation is done, you will have this pop-up window that says restart your session. And what happens is in Collab Notebook, sometimes whenever you are installing certain library, you also need to install the dependencies of it. And there might be few mismatches. That's where a few times you need to restart your session, and everything works fine once the session is restarted. Cool. So now that I've clicked on session restart, I'll just go ahead and I'll import few statements. Import, I'll just write import from Beyond LLM. We need to import source, retrieve, embeddings, LLMs, and generator. So source is used to get your external data and do the chunking. Retrieve is to get the similar context. Embedding is used to convert your text into vector format. Large language model is to generate the LLM based responses. And then you have generator. What generator does is it will connect the pipeline of your user query, retriever, large language model, so that you can use it to build the RAG pipeline and as well as the evaluation. So before we can proceed, so let's see how you can use LLMs. How to use LLMs in Beyond LLM. All right. So first thing is you need to set up your API key. I'll create one more subheading. Set up your API key. For that, I need to save the API key inside environment variable. That's where I'll import OS, os.environment. Okay, I'll also install from getpass, import getpass, and one second. And then you need to save your API key inside the environment variable. And the command is os.environment. And for Google API, you need to enter Google colon API, then key. Everything needs to be in capital. And then you just write get pass, enter your Google API key. So I'll stop sharing my screen and I'll copy my API key and I'll get back. Uh, Shiva, can you confirm if my screen is visible?
Yeah, I added it to the screen.
Okay. So in order to proceed, since you need to get your API key, you need to open Google AI Studio and you just have to click on Get API Key. So once you click on Get API Key, you can create a new API key by just clicking Create New Key, and you just have to give the name and it will create the key. Now I'll just copy this and I'll come back to the collab notebook. I'll just run this and I will paste the API key. All right. So what we have done so far is we have imported the statements from Beyond LLM, and in order to proceed, we need to check whether the LLM is working fine or not. That's where we need to set up the API key of Gemini. And now I'll define LLM. LLM equals to LLMs dot Gemini model, and I'll write a user query, simple query. Hey, how can you? And in Beyond LLM, if you want to trigger the particular LLM, you just have to run LLM dot predict query. So it just takes few seconds and it will generate the response. All right. So as you can see, it has generated a response, and this is how the Gemini LLM can be used. And not just Gemini LLM. If you want to use OpenAI or any other LLM from Beyond LLM, you just have to define it, and then you just have to use the function called predict, and it will generate the response. Cool. Now that we know that the LLM is working fine, the next step is we need to get the external data. Get the external data. And there are four parameters that you need to define. The first parameter is the data. The data, if it is YouTube video, it can be URL. If it is CSV or PDF, you need to pass path of the file. You can also use PPT. You can also use a file which is TXT. So whenever you are using file, you have to add the path of it. If it is a website or a YouTube, you need to give the URL, and then you have Notion support as well, and you have Drive. And the second parameter is D type. So what D type says is the data type of the data that you are passing. So it is just PDF, CSV, YouTube. You just have to define what the data is about. That's it, simple. And then you have chunk size, and then you have chunk overlap. So these are the four different parameters that you can use. So let's define the data. Data equals to source dot fit, and data equals to, I'll just pass the YouTube video. So this is the module one. For module one was about introduction to RAG and agents bootcamp. I will use the same link. I'll copy this link and I will paste it here. And then you need to define D type. D type is nothing but YouTube. And then you have chunk size equals to 512. And then you have chunk overlap. I'll just keep chunk overlap to be 0 because I don't need any overlapping in this particular use case. So I'll just run this. So it's showing the YouTube video that you have added. And in order to verify if you are getting the external data ready, what you can do is you can check what is the length of the data. So it is 26. That means the 1 hour video of the module one, it has 26 different chunks of 512 context. And if you want to verify what is the data within it, you can just run data, the index that you need, dot text, txt. And here you have the data. So as you can see, it's starting from okay, we are live, hello everyone, and you have the additional data as well. Just like this, based on any chunk data, you can get the information. And not just the text data information, you have additional metadata as well. And if you need to get the additional metadata, you can just write data, and it will show us the different metadata that you have. One more is the node link. Then if you see here, metadata, it has the YouTube video link, and it also has other time data as well. All right. So I'll just revise what we have done so far. Okay, so we started with the first step. The first step is you need to use source. How did we get source? Let me remove the output. So from Beyond LLM, we imported source, retrieve, embeddings, LLM, and generator. From the source, we just have to use source dot fit, and you're passing the data that you need. You need to define what that data is about, and you have to define this additional two parameter to chunk your data. And once the chunking is done, your entire data context is converted into smaller chunk. And if you want to verify it, you can just run .txt to get your data. Cool. Now that we know we have successfully loaded the data, the next step is you need to store that inside a vector database. In our case, we will be using in memory, and this process is also called indexing. So what happens in indexing is you're converting your data into embeddings, which is the vector representation, and you're storing that in a vector database. So I'll define it to be retriever. This is the first step of your retrieval augmented generation. What happens in retriever? Given the user query, you are getting the relevant documents. This relevant documents, you are getting it from a retriever. How is it possible? We will try to check just two lines of code. Here I will define retrieve dot, you have something called as auto retriever. So retrieve again is imported from beyond LLM dot auto retriever, and you just have to pass data. And by default, the embedding is Gemini embedding. If you want to use additional embedding, you can define something called as embedded model. So if you are able to see this, there are two different parameters. Let me write the parameters first. One is you need to pass the data. One is you need to pass the embedding model. Embedding model is nothing but embed model. And then you need to define the type of it. Type can be normal, it can be cross rerank, then it can be hybrid, then you have something called as flag embed. Let me recheck it from the documentation. So this is the documentation again. I'll just click on auto retriever, and as you can see, you have normal retriever, you have flag embeddings. For flag embeddings, you need to add flag rerank. My bad. So this is nothing but flag rerank. Let me come back to the documentation. Then you have cross encoder re-ranker, and for cross encoder, you just have to use cross re-rank. Cross re-rank. So these are the four different types. And the last thing is you can define top K. So what is this top K? We have 26 chunks in our data. Based on the user query, how many relevant documents are you supposed to return? So this is where you need to define top K. So top K, ideally, it can be 5, it can be 10, it can be 20. This depends again on use case. And this is the hyper parameter. We don't know the actual size, but this is where you need to hyper tune, and you need to see which chunk size or how many chunk size is giving me the better result. So this is what happens in the indexing, which is your auto retriever. And I'll define the type. Type is nothing but normal. And if you want to define a custom embedding model, let's define that. Embed model equals to embeddings, embeddings dot Gemini embeddings. And then we need to define top K. Top K, I'll just keep it 3, and embed model equals to embed model. All right, so here I'm defining total 4 arguments. One is the data, that is chunked data, and then you have normal, which is your re-ranker type or normal retriever type. Then you have top K that defines how many relevant documents that you need to pass. And then you have embed model, which is your text to embedding model, which is Gemini. And now I'll just run this. Cool. So before I can proceed, let's take few questions if in case someone is facing issues. And I also have a demo notebook so that if anyone is still lagging behind, you can make the reference from here. So let me share this to you. So do we have any questions?
Yes. Someone was
Okay.
asking about a child.
Okay, so RAG challenge is basically using Beyond LLM. You're supposed to build a RAG pipeline. You can use Streamlit, you can use Gradio, and you can build any examples. So you can check out Beyond LLM examples. You will more. So we will pick three of them, and the three best examples will be merged in the PR, and they will be getting this works. So this is part of Bootcamp, you can say. So I've shared the collab notebook.
Yeah.
What optimization techniques can we apply to enhance efficiency and accuracy of our RAG pipelines? Are there any best practice for tuning these models? Okay, so one of them is you can use advanced techniques such as re-ranking is one of them. And one more way how you can enhance the accuracy is you can use something called as fine-tuning embeddings. So what happens is whenever you're building the RAG pipeline, you have the external data. There are high chances each token might not be passed within your embedding model. This is where based on your data, you need to fine tune the embeddings so that you can enhance the accuracy of your RAG pipeline. And in the retriever side, once the data is passed with embedding, on the retriever side, you can define hybrid search. So what hybrid search does is it will look into both your keyword search and vector search, and it will give you the better result. So that if there is any question which is out of context, the keyword search will limit over there. And if you still want to create an efficient pipeline, the next thing is prompting. Prompting happens on the generator side, where you have to give very strict instructions to the LLM so that it doesn't give false response. And there are few more techniques such as guardrails. Guardrails is used probably in most of the RAG pipeline. You can use guardrails as well. What what are the most efficient evaluation metrics for? Okay, so as of now, for evaluation metrics, we have context relevancy, answer relevancy, groundedness. This is with Beyond LLM. And also, if you look at TrueLens, which is another library, even they have the similar metric. They have one additional called feedback. And one more additional library is Ragas. Ragas also have similar thing. They also have ground truth and other metrics as well. So these are the three metrics. RAG, triad, you can search for it. Oh, can we do only the schematic search with Beyond LLM? As of now, schematic search, we don't have schematic search in the sense, do you mean for chunking or for the vector search? Okay, I'll take that question again, but I'll again share my screen and I'll revise what we have done so far. If you're
All
still
right.
lagging behind, you can check out the collab notebook which is shared. It's the similar thing, but we will do live. Okay, so I'll revise again. First, we define the particular LLM. In LLM, we are adding your Gemini API key, and we are just testing if LLM is working fine or not. Then you need to get your external data where you have to define four parameters. One is the data. It can be CSV, PDF, and so on. Then what the data is about, you need to define that in D type, which is the data type. Then you have chunk size and chunk overlap. I've already defined it earlier. And once you have the chunk data, you need to pass it inside the retriever. For retriever, the first parameter is the data that you have loaded from the source. The second thing is you need to define the retriever type. The retriever type in our case is normal. Then you have top K. Top K is nothing but how many documents or chunk for the user query you need to give it to the user. And then you have embed model. Embed model is default Gemini. If you want to define it, you can define. If not, you can use additional embeddings such as OpenAI, Hugging Face, and flag embeddings, again, which is from Qtrend. You can check out the documentation for it. Okay, now if you want to verify what is the context that you are retrieving, I'll define context. Context equals to, let me define the query. Who is Tarun Jain? So since that particular video had the introduction of mine in the beginning, that's the user query. I'll just write user query, and you need to define the context. Context equals to retriever dot retrieve, and you just have to pass user query. So now what will happen is, based on the user query, you will get the number of k context from your retriever. I'll just print length equals to context. So this should be 3. Context length should be 3. And if you want to get the data, you just have to run context 0.txt. Okay, not sure why it's taking time. So as you can see, the context length is 3, and the value of context should be similar to top k value that you have defined. So if it is top k is 5, then the length of context will also be 5. And if in case you want to verify what is context getting retrieved, again, the same parameter that you have used for data, you have to use it here. From the first context, I need to print the text. And if you see here, I have the role here, like I was part of Red and Labs, CA Microscope, and data scientist at AI Planet, Google developer expert in AI/ML. I have the information in my first chunk. So there might be chances where your first chunk might not be relevant. That's where your type will be re-ranker. And this is something you can experiment when you're working with BeyondLLM. And now let's define the pipeline, which is your generator. Define pipeline, that's your generator. For generator, you are again defining 4 parameters. One is system prompt. And if you remember, in the second step of RAG, you are using something called as augment prompt. So augment prompt is nothing but you give the system prompt, you give the user query, and then you are building the RAG pipeline. So first thing is you define the system prompt. The second thing is you define user query, which is the user prompt. Third thing is you have retriever. Whatever context it is getting retrieved, you need to pass that inside the pipeline. And last thing is you need to use something called as LLMs. By default, it is Gemini. So again, let's define these 4 parameters. Pipeline equals to generator dot generate. The first thing is system prompt. I'll just write you are an AI assistant just for the example. Here you need to be very specific when you give the system prompt. If in case you are building any medical based RAG pipeline, you need to tell you are a medical chatbot, you only answer related to medical queries. So this is where you need to define the system prompt. In our case, since it is just a YouTube video, I'm just telling the LLM to behave as a AI assistant. And then you have question. Question is nothing but the user query. Here the user query is nothing but who is Tarun Jain. And then we have retriever. Retriever equals to retriever. And then you need to define LLM equals to LLM. So these are the 4 different parameters that you need to define. One is system prompt, one is user question, then retriever, which has the context, and large language model. And once you define this, you can just run pipeline.call. So what pipeline.call will do is it will generate the AI response. The AI response is nothing but whenever you're connecting a large language model to your data, you need to use pipeline.call so that you can get the response back from the LLM. And then we'll be using evaluation. For evaluation, again, there are different things. We have context relevancy, we have answer relevancy, we have groundedness, and then you have something called as ground truth. So these are the four metrics that we provide. All right, so as you can see, the response is already done. I'll run pipeline.pul. Okay, so if you see the response, Tarun Jain is a data scientist at AI Planet, which is correct. Then it has two other roles, Google Developer Expert in AI/ML, contributed to Google Summer of Code 2024. It didn't take Redden Labs properly, but again, if we verify the context, it is read as, where is it? So if you see here, instead of Redden, it was, the transcript was regarding red hand, which was misspelled in the data itself. And then you have CME microscope. Again, it was CA microscope, but that was again on the data part. Cool. So now that you are getting the AI responses, what you can do is you can experiment with the different system prompt, and you can ask user query which is out of context, and then you can check if you are getting the response or not. And now let's come to the evaluation part. And if you want to run the evaluation, context relevancy, answer relevancy, and groundedness is what you call as RAG triad. I'll just write the above three metrics are part of RAG triad evals. So now what I'll do is I'll run RAG triad evals, print pipeline dot RAG get RAG triad evals. So this will take some time, few seconds, and it will generate the metric. So the metric will be related to these three things, what I mentioned it here. So as you can see, the context relevancy is 3.7. I'll tell you the reason why it is 3.7. So when you look at the context, right, we have three different contexts. You have context one, context two, and context three. If you see three different contexts. So the introduction of mine is only in the first chunk. It's not there in the second chunk or third chunk. So obviously, when you're evaluating your response with the context relevancy, if the context two and context three doesn't has my information, then context relevancy will be very less. And now if you look at answer relevancy, whether the response, if you look at the response, is it matching with the question? The question is, who is Tarun Jain? So if you look at the response and if you look at the question, it is correct. And that's where you are getting the accuracy as 10.0. And what groundedness will do is it will take your context, it will generate the data set, and then it will evaluate. So in the generated data set, we have the information of who Tarun Jain is, and it is defining the metric behind it. So this is where you need to define based on the use case, which metric is better. So if your data has information in each context, then context relevancy is for you. If you just want to evaluate between the response and the question, then you can directly use answer relevancy, and you can try that as well. You can just use print pipeline dot get context relevancy, and if you print this, you'll only get the context relevancy score. Pipeline dot get answer relevancy, you'll only get the answer relevancy score. So it takes around 8 to 10 seconds to generate the response, even for the LLM and as well as the evaluation. And if you want to enhance this, then probably you can use GPUs and all. So this is it from this particular session. And again, I'll open my slides so that I can tell about the competition. One second. Okay, so I hope the slides are visible. The RAG challenge is mainly about you can add your examples either in cookbook, you can add your examples either in examples, and the best three will be selected. And once the PR is merged, we will be sending out swags to that particular person, and we'll have a Google form that will keep track of all the participants. And don't forget to star and quote the repo so that we have the support for the open source project as well. Cool. So if there are any questions, probably we can take those.
Okay, so the previous question we had about uh, semantic search.
Okay, so if you mean the normal vector search, then yes, we support that in Beyond LLM. And you can use hybrid as well, where it will support both schematic and as well as keyword type. Okay, so if you want to try something out of vector search, then I don't think we have the support as of now. We need to add support to that. What are the some areas where Beyond LLM is better than other frameworks like LangChain? The one thing is, as I said, the main goal of Beyond LLM was to have quick experimentation so that you don't have to write extra lines of code. So we mainly treat Beyond LLM to be a tool where if you want to see which is the efficient RAG pipeline you want to build, and if you don't want to spend much time on deciding it, you can just spin up the particular parameters and you can get your result. So that's one area. Second, the evaluation as well. Evaluation, we are trying to add more eval support, which is currently ongoing, which is completely different than LangChain. You can check out the code base as well since it's open source. It's not dependent on other libraries. And third thing is observability. For observability, currently we are using Phoenix, which will keep track of all the these things you are using. It's similar to what we have in Langsmith, but we are trying to enhance the dashboard of it based on our LLMs that we have, so that we'll also add the support of open source observability, which will have different keys that you'll be tracking. Like for OpenAI, if you are tracking the cost, latency, and tokens, for open source, you'll be tracking something different. So we are currently on that particular phase of adding the additional feature for observability and also the function calling part, which we are currently looking focus on. What all vector DBs can be used with Beyond LLM? As of now, we have Chroma and Qdrint. We have few examples as well. So if you open the examples folder, let me show it. So in examples folder, you have something called as vector DB usage. In that you have app and engage data, which is using Chroma DB, and you can change it into Qdrint as well. How are the evals generated internally using prompting? Yeah, it's via prompting. Can we evaluate code generated LLMs such as? Yeah, you can evaluate it as well. So you can use custom evals as well if in case you want to have different metrics that you need. And if you know how to write the code of it, we have the support of writing custom template for it. Is there a simpler way to add multiple PDFs without having the list of each individual? So here what you can do is, suppose if you have multiple documents, right? Like if you have 10 to 20 PDFs, what you can do is you can directly upload the directory. So here you have to again use the custom template. So in custom template for your D type, it will be simple directory loader, which is just dir. Instead of using PDF, instead of using CSV, you will define it as dir, and you have to define the path of your directory. So that's one possibility. Probably we'll open the PR for it today. It's just the custom component which we have in the internal team. We'll just give the support in the documentation. It's possible, but just you have to use the directory instead of the individual path.
Okay, I think that's it for the questions. So, before we wrap up the session, do you have a final advice or some words for
Yeah.
the viewers?
So actually, in the module two, there were few queries by many people saying that how to use Llama index with the vector DB. So what we have done is we have added the new collab notebook. So I'll just share that and I'll do a quick walkthrough. So this is the new notebook that we have added. I hope this screen is visible.
Yes.
Okay, so again, the module 3 and module 4 is live. If anyone has not yet opened the Bootcamp access, you can check it out. And there is one change in module 2. We added this new collab notebook, which is regarding ChromaDB vector storage using Llama index based on the messages that we received on Discord. So here mainly, since it needs to be accessible to all, we are using something called as fast embeddings, which is an open source embedding model from Qdrun. Then you have Hugging Face API, which is the Hugging Face hub, the LLMs that we are using. So once the installation is done, you need to set up your Hugging Face access token. And in order to get your access token, you need to enter huggingface.co settings token, and you need to create a new API key. So once you get the token, you just have to paste it here. Uh, Here you are able to use any open source model. So how is Hugging Face API or Hugging Face Hub different than Hugging Face pipeline? So Hugging Face pipeline, you can use any LLM, but the thing is, you need to load that locally, and it will take GPU to load that. So what Hugging Face Hub does is, within 10 GB of any model on Hugging Face Hub, you can use it anything. So the 7 billion parameter models such as Mixtral 7B, Gemma 7 billion parameter model, you can use that model without even loading. So it saves time, and you don't even need GPUs for it. So that's the reason why we are using Hugging Face API LLMs. And now, if you look at this step, you need to create a new data folder. So the first thing is simple directory reader. You need to create a data. Inside the data directory, you can upload any file. It can be PDF, it can be PPT, it can be CSV, and you just have to load the particular directory. And this is where someone asks the query, right? What if you want to use multiple paths? You can add that inside the directory. And since in Beyond LLM, the source.fit is dependent on Llama index, you can do that as well. And then you have something called as fast embedding. Why are we using fast embeddings? Because the model is loading in Onyx format, which is pretty fast. And this was developed by Qdrun team. And here you can define any open source model. They have limited support for the models. And one of the best performing is the NLPR GTE Large, which is the open source embedding model. And here you're defining the Hugging Face LLM. And if you run this particular cell, right, Hugging Face Inference API, this FR model, it won't load the model files. Rather, the model is inferencing on the Hugging Face server. It's not running on your local system. So this is where you don't need GPU when you're using Hugging Face inference. But the only downside is you can't use any LLMs more than 7 billion parameter model. So the limit is 10 GB itself. And here, this is very important. So if you are a very old developer of Llama Index, in the initial uh, in the initial version of Llama Index, we had something called a service context. In service context, we were updating the large language model and embedding model. But in the newer version of it, they have added something called as from llama index.core import settings. So this is the alternative for service context, where you can directly override the default LLM. So by default, Llama Index is using OpenAI as their LLM and OpenAI embeddings for their embedding model. If you want to override it, you just have to write settings.llm, which is your Hugging Face, and embed model is your fast embeddings. And now comes the very important part on how you need to define the vector storage. The first thing is you need to define the persist client. So what persist client does is it will create a directory called ChromaDB. So a new directory will be created whenever you index your document. The index metadata, this SQLite JSON file, everything will be saved as the collection inside ChromaDB. So this is just one-time process. Whenever you upload your document, suppose I upload Ikigai PDF, whenever I upload the same PDF next time, it will get the data from the collection that I've already created. So this is only one time you're supposed to do. Once you create the indexing, you can directly load it. So in order to load, you can check the difference. Here you're adding your data, and in load index, you are not supposed to give your data. So it's here. When you are creating the index, you have vector store index from document. Here you are passing the documents. So documents, you have to do it only once. And when you are loading your data inside your indexing, you just have vector store and embedding model. And this vector store, you're just loading the model from ChromaDB. So you don't have to pass document when you're loading it. So this is the difference, and this is very important when you're building any RAG-based pipeline on production or on Streamlit for POC demos. And once this is done, you just have to run the query engine. Query engine is like the generator that we have in Beyond LLM, and you just have to run the particular query and it will generate the response. Yeah, so this was something that we added recently so that if anyone were facing issues, you can check this Collab notebook for the vector DB support. And one more thing, like there are few this thing, like if you open few notebooks, you are not able to see the notebook files. So if you look at re-ranking, okay, I'll open simple rack. So few of the notebooks you are able to get the data. For few of the notebook, if in case you're not able to load it, you can just click on the download button. So once you click on the download button, you can open that locally. So we are trying to fix this issue. Meanwhile, if in case you're not able to see the notebook, just click on download.
Okay, so we
This
just
is a
have
different
one
question. When to
question.
use LangChain, Llama Index beyond LLM? If you want to use any application on production, then you have to use Llama Index. That's your RAG pipeline. Beyond LLM, suppose if you don't know or if you're experimenting whether hybrid search will work fine or not, if you're doing the hallucination check, right? And for hallucination check, you have different methods that you need to try. That's where Beyond LLM comes in, where it will help you with quicker experimentation and the evaluation part. If something is wrong, then you can do quick experimentation and you don't have to write additional lines of code. So that's when you can use Beyond LLM. And LangChain, again, like if you want to learn RAG for first time, for beginner friendly, LangChain is useful, but not on production.
Okay, I think that's it.
Cool, yeah.
Thank you so much, Tarun, for the insightful and comprehensive session. We really appreciate the time and effort you put into the presentation. Uh, I think we can end the session now.
Yeah, good luck with the
Yeah,
bootcamp
yeah,
and do participate in the RAG
yeah,
challenge.
yeah. Thank you.